All right, and then for multiplication of radicals. This can be done if the radical hats are the same, meaning it's all a bunch of square roots, or it's all a bunch of cubed roots. There's another way to deal with it if it's not. But what we do is we multiply our outside numbers together. We multiply our inside numbers together. And we reduce the radical. So we have negative 3 square roots of 5 times 2 square roots of 10 times negative 4 square roots of 2. Notice I said only if it's the same radical hat, not the same radical. So the number underneath the radical doesn't matter. The root is what matters. These are all square roots. See if you can find that answer on your own.
Wait, if it doesn't,
What's that?
I was confusing with the other one.
We're multiplying now.
But if they had a cube root, you have to leave it alone by itself.
If they had a cubed root, I'm going to show you what to do on the next slide. We're going to use fractional exponents to be able to combine them, which is why we need to know how to change from one to the other. What's this answer? 240. Because the whole numbers multiply to give me positive 24. 5, 10, and 2 multiply to give you 100, and 100 is a perfect square. Square root of 100 is 10. So our answer was 240. Very good. Very good. Okay, so to answer Ryan's question, what do you do when the radical hat is not the same? Well, that's when we use fractional exponents. Because we cannot simply combine the x to the 5th and the x to the 8th, because are we going to put it under a square root or a cubed root? And you can't just say, oh, well, let's just add those two together. It doesn't work that way. So, when you're multiplying and the radical hat is not the same, you're going to change each radical to a fractional exponent, which means this first one becomes x to the what? 5 halves. Even though the little 2's not here, it's understood. And remember, this is the denominator in the fraction. So x to the 5 halves times x to the 8 thirds. All right, now we revert to what is the operation that we are performing here? To the variables. What are we doing to the x's? You are multiplying variables. So what do you do with the exponents when you're multiplying variables? You add them. So we've got to add x to the 5 halves plus 8 thirds. Okay, well, let's go to our rules for fractions. What do you need when you're adding fractions? A common denominator. What would the common denominator be?
6.
All right, which means 2 goes into 6, and 3 times 5 is, and 3 goes into 6 twice, and 2 times 8 is 16. So that gives me x to the 31/6. Now, let's turn that back into a radical and reduce it. What root is that? The 6th root of x to the 31st power. Is that simplified? No, because there are groups of 6 in 31 x's. How many groups of 6 are there in 31? There are 5 groups of 6. Which took up how many of these? What's 5 times 6?
3.
So I have 1 left under the radical. X to the 5th times the 6th root of x. When you simplify these, this is part of this radical, 6th root. You have to have that 6 there. It doesn't change to a square root. It's still a sixth root. Okay, well, we went a lot faster today, but I'm gonna stop here because that's where I stopped the first hour. And we'll pick up from here tomorrow.